we're going to show that two quadratic functions which have the same derivative must be different or must differ by only a constant value. So what does that even mean? Well, what it means is that if we've got two functions whose derivatives are the same, that the two functions, let me give you an example. Let's say f of x is equal to 3x squared plus 2x minus 5, and g of x is equal to 3x squared plus 2x minus 7. These two functions have the same derivative, but they only differ by their constant value. Okay? Now here's what we have to be careful with. We can't start out with two functions that differ by a constant and show that the derivatives are the same. That's logically not correct with what we have here. We have to take two quadratic functions that have the same derivative. So let's say f prime of x is equal to, now the it's going to have some derivative. Now the quadratic derivative, or the derivative of the quadratic function, is going to be linear, and it's going to be given by 2 times a times x plus b, okay, if f of x is equal to ax squared plus bx plus some constant. Okay, so if this is the case, then this is the derivative. So let's say we've got a function that has a derivative that's equal to this, and let's say there's another function that has the same exact derivative. Well, then what does g have to look like? Well, clearly g has to look like ax squared plus bx, because it's got these values, just like this, it got these values. So these guys and these guys must be the same. But the c value, do you see how the c value doesn't play any role in f prime? Okay, well, whatever value is here does not have to be the same as c, because it doesn't play a role over here. The only thing that plays a role are the a's and the b's. So the c's and the d's here, they don't matter. And so what we've got is now two functions, f of x and g of x, where c does not have to equal. It can equal it, but does not have to equal d.